the four co-organisers. I think you probably gathered from David's introduction that I am Paula, out of the four. Might have been a tricky guess. The other co-organisers are Peter Challoner, who's over there, Peter Cox, who's here, and Felix Eidenbrod, who's there. And you'll see them throughout the course of today as they're sharing various sessions for those of you who are new. Well, I see lots of familiar faces in the audience. So for you, those of you who have been here in the opening workshop and throughout the programme, I'm going to provide a little bit of background and some information on some of the conceptual understanding that underpins the programme and some of the issues we've been tackling while we're here. So for those of you who have been involved, this is a bit of a refresher. For those of you who are new, again, it just makes sure that we're all at the sort of the same stage before we launch into some of the talks that will follow mine. So, let me move on. So, as background, many of you will be aware that the programme here is linked to the Landscape Decisions Strategic Priority Fund. This was a fund that was launched by UKRI with 10.7 million. And the programme's aim is to develop a new understanding to help individuals, communities and the country make the best choices on how we manage land use and the decisions we make about land use in the UK. So how does this programme fit within that overall aim? Well, here we're discussing the parts of the programme that involve enhancing collaboration between the mathematical and the environmental sciences. And to do that, we're looking at what are the mathematical and statistical challenges in landscape decisions, and in particular in modelling landscape systems. The programmes run throughout the whole of July and into the beginning of August, and I'll tell you a little bit more about how that's been structured. It was informed by a scoping workshop that some of you may also have attended that took place in September last year. So what have we been trying to achieve? So in terms of the Landscape Decisions Strategic Priority Fund overall, that's to provide improved tools to support landscape decision making in the UK. In terms of this particular Newton Institute programme, we're exploring some of the mathematical challenges associated with improving tools, but particularly in how we can make use of data on observations to better understand historic land use change and land decisions, but also how do we project those land use changes into the future. So what we've been doing, we have this opening workshop between the 3rd and 5th of July. Actually, we seem to have lost a day there. So that was a 3-day workshop at the beginning. And what we did there was we had initially an open for business day, so it was a mixture of stakeholders and academics. And the idea was then to try and understand more about what the need was from the stakeholder community in terms of how they would like science to help them provide an evidence base to help inform their landscape decisions. That was followed by a series of different academic perspectives from both the mathematical and environmental sciences on various different topics related to landscape decisions. And there we were trying to establish the state of the art and where were the research gaps that the programme should then focus on. We then had the 4-week programme, which was lots of brain work for those who were here, where we had sessions with seminars, sort of more formal discussion groups, and then lots of informal conversations to develop ideas together. And now we're at this closing workshop where we want to sort of report on progress, what we've been doing during this particular programme, and particularly start to look at what are the key priorities going forwards that have been identified during the programme and that we can just discuss with you, and then bring to the Open for Business Day on Friday, when again we will be joined by more stakeholders, and we can then see what their reaction is to the research priorities and the research roadmaps for going forwards that we think need to have some emphasis on in the future. So this is, I'm going to just take you a little bit through the conceptual framework that we developed before we came into the programme, between the four organisers, although when Peter presented this at the opening workshop, I think he put all of it on my shoulders, so I'm spreading it now back amongst the four of us. For those of you who've been in the programme, are probably quite familiar with this by now, so I will just talk us through. But I think it's useful for us to actually understand what do we mean by the landscape system, what are the components of that landscape system that we've been discussing in the programme that we need to represent in modelling tools. So first, if we want to try and understand the state of that landscape system, we have, if we think of the landscape system as a sort of complex social ecological system, or some people might call them a human environment system, but there are those two major components are the state of the ecological state, so that might include the processes around biodiversity, the hydrological cycle, the biogeochemical cycles, but at the same time we have the state of the socio-economic system, and again this is important to also understand there are human processes, there are social processes that that help us understand where the demand for different services that come from land are, and the different attributes and values of the society that we are trying to make the landscape system decisions deliver to. So they jointly produce a whole range of different land services. So the food that we eat, the water that we drink, bioenergy, housing for our populations. But of course we only have a finite resource of land and other natural resources such as water. So there are decisions that need to be made because there are often trade-offs and synergies between how we choose to use our land. And of course what we do with our lands and the services that we provide to society will affect people's human well-being and health in many different ways. And of course that land system is subject to many pressures of change. So this can be changing population in different areas, changing markets, changing effects of policies. And those changes affect the state of the landscape system. And sometimes that might affect them and provide opportunities, or it might provide risks or effects that we would then trigger responses such as policy planning and strategic decisions, where we want to try to reduce any threats that come from pressures. Or those responses might actually try to increase the capacity of society to cope within our system. So for example, by that I might mean if we're thinking of climate change adaptation, we may be thinking of things like early warning systems for flooding, increase the capacity to cope. Whereas if we actually want to reduce a threat, we might be thinking more of sort of climate mitigation policy that might then act on the system and down through the different pressures. And of course, how we define our social ecological system will affect how we define each of those components. So this could actually be quite local scale. It could be an individual farm holding that we're trying to make decisions on, or it could be a local authority region, or it could be the whole of the UK. And that affects how we define each of those components. But they also don't exist in isolation from the rest of the world. So even though the UK is an island, it doesn't actually assist in terms of drivers and pressures in isolation. And also the UK signs up to many international agreements and has to provide to those international agreements. So we have to remember that how landscape decisions are made in the UK are nested within what happens within a broad international context or in the larger Earth system. And those drivers influence our own pressures on our system. They also affect the options, the different responses that we can implement. And they can also be used to reduce a threat. So some threats are global in nature, particularly climate change mitigation. So together, collectively, we sometimes have to act with many other countries around the world to reduce threats that we can't do on our own within our own national boundaries. So, if that's the system we're trying to model, I think we've probably all agreed in discussing it, it is a fairly complex system, and we don't always need to handle all of those components of the system at the same time, depending on the decision context that we're trying to deal with. So what we've been discussing while we've been here at the Newton Institute, again, we've been trying to work about how collaborations between maths and environmental science can help in very different aspects of trying to model that landscape system. And we've been looking at these broad topic areas. These are not distinct areas, they overlap. There's many different issues within them. And how we structure this closing workshop is you're going to get some insights into each of those areas from people who participated in the program that will lead to some general discussion. So this is just to show how we've been working. So we have been brainstorming on many of those issues that were on the previous slide. We work in more formal ways in the morning, but in the afternoon we have a great space upstairs, if you haven't seen it, for lots of informal meetings, lots of chalkboards where we can put lots of ideas together, and a very specific outcome, if you want to look at the chalkboard upstairs near the tea and coffee, is a whole list of ideas that were formed to address the large maths call that came out of the landscape decisions SPF, where the deadline was last Friday. So that's a very specific outcome where we put different disciplines together to try and actually address some of the issues we've been discussing. And you will hear more about some of the ideas that have been coming up as we go through this workshop. So just in terms of how we're going to structure this workshop, so today and tomorrow is mainly academics coming together, and we'll get those academic perspectives on some of those key research challenges structured by 5 broad topics, which were the ones that I was listing earlier. So you'll get a couple of presentations on each topic, on the kind of things we've been discussing, getting a personal perspective from different individuals who participated in the program. We've tried to get a variety of different perspectives, ideally someone who's more mathematically orientated and someone who's more environmental science orientated, to give you a more encompassed picture. And each of those is followed by a bit of a panel discussion, so you can bring your own points into the discussion. At the end of Thursday, we have breakout groups. And again, this is so that we can give you the opportunity to feed in to the key research priorities that we're trying to roadmap by the end of this closing workshop. And we'll try to sort of collect ideas as we go through each of the panel discussions and bring those into the breakout groups on Thursday. And then there'll be a reporting back and general discussion as well at the end of Thursday. And Friday is slightly different. We have this open for business day, so we'll have more stakeholders in the room. And there we've tried to pair the academic talks with stakeholder talks, so we can both present what we think is a synthesis of where we've got to in the programme, and at the same time what are the major research priorities going forwards. And we start to get some stakeholder reactions, both from DEFRA, from NERC, and potentially from a whole range of other stakeholders as shown in your agenda. And in terms of some of the issues that may come up on Friday, these are some of the issues that came up from the stakeholders in our opening workshop. And I've just put this here again because we're now going into the next few days with mainly academics in the room, and it's quite useful just to remember this framing that comes from what are the needs of the stakeholders. And again, it is quite difficult to tie these down to specifics, but some of the issues we've been told about, particularly from DEFRA, is they want to know is if they have a particular policy or an intervention, they want to be able to use models or mathematical tools to know if it will have the desired impact that they want it to have. At the same time, they also want to know, are there other co-benefits from that policy or intervention, or are there unintended consequences that they haven't considered that might result from that policy or intervention? They also want to look at it from the opposing side. So instead of going from a specific policy or intervention, they might go from a goal or an outcome, and they want to know how can they achieve that goal or an outcome. So the example there could be how do they achieve net zero CO2 equivalent emissions by 2050 in terms of what is the landscape's contribution to trying to achieve that goal. A similar goal might be we have very strong afforestation targets. How might we use the landscape to deliver those afforestation targets, bearing in mind what the co-benefits or potential unintended consequences may be? And of course, at the opening workshop, uncertainty came up quite strongly. It's an obvious area, I think, where the mathematical and environmental sciences can work strongly together. So we were asking DEFRA what did they need, what was the information that they needed in terms of uncertainty assessment around modelling. And their view was really they need to know how they can de-risk a policy or an intervention. So they were very interested in the bounds of uncertainty, understanding the sensitivity around a decision, but ultimately it comes down to them minimising risk. And it was also clearly stated a lot during the opening workshop that we need to work with data sources that are currently available. So we might have aspirations and make notes that new data is needed in certain areas, but actually because there are immediate needs now, we also need to be able to be aware that we need to be developing methods that use available data sources to address the questions of importance now. So that was all I wanted to say as by way of introduction. Now, those of you who were at the opening workshop may remember I woke you all up with Mentimeter as the only time you were allowed to use your phones. And I'm going to repeat it. So this will be exactly the same questions as the opening workshop, so it's kind of an icebreaker. But it will also be interesting to see if we have the same spread of answers as we have at the opening workshop. So I do have the results from the opening workshop captured on slides at the same time. So we do have new people in the room, so it'll be interesting to see if our spread of experience of who is in the room has changed. But also it might be interesting to see those who've been in the programme for a month, whether they actually view their background and expertise any differently now to they did when they came at the beginning of July. So if you could go to menti.com and put in that code. I can just write the code on here, because I'm now going to change screen. Okay, so I can see some people are already in there. So the first question, as those of you who have already seen, was to put in an answer on what your main disciplinary background. And again, as before, you are limited to putting one here. So you have to put what your main disciplinary background is. We have mathematics, statistics, computer sciences, environmental sciences, physical sciences, biological sciences, social sciences, interdisciplinary sciences for those who don't want to be pigeonholed, and others for those who can't decide. So you've put in your responses. We've got 29 so far. And I think at the opening workshop we got up to about 50 to 54 people were voting, maybe slightly less in the room this time. We'll give you a few minutes to put your votes in. We definitely at the minute have more mathematicians in the room than across the other disciplines, and a distinct lack of social scientists. Is anyone still voting?
I just opened the second window, so there were two chairs.
Yeah, no, that's okay. So we move on to the second question. I will show you the results from the previous workshop after, because I just need to go through the questions. So here we've definitely got many more mathematicians in the room now. It's still changing a little bit, but a lot of people who already think they work on interdisciplinary science. Okay, so the next question, I'm going to move, is in which area of the landscape system do you mostly work? And here actually you can put multiple choices into the voting app. The choices are agriculture, forestry, biodiversity/ecosystem services, urban, water, soil, climate, energy, natural hazards, the landscape system as a whole, for those who, again, don't like to be categorised and like to work systemically, and other, again, for those who think they work somewhere differently. So that's much, much more even. We have quite a lot of biodiversity people, and lots of people are working on the landscape system. So this will be interesting to actually see if this is higher than in the opening workshop, to see if people are now working on the systems rather than individual parts of it. And we have a lot of others. Can I just, if anyone who wrote other, or clicked on other, would be willing to sort of let us know what we missed in our categorisation?
Food.
Food? There is agriculture, do you count?
That's not all of food, is it?
Okay, okay. Fine. Anyone else? Okay. All right, no worries. So we had 33 votes again, a lot of biodiversity people and a lot of landscape system people. So the last one is, which modelling approaches do you work with? Again, you'll read this in better detail on your app, but just to clarify the many acronyms, because it wouldn't all fit on the slide. So we've got the CGE and PE models, computable general equilibrium, partial equilibrium models, ABMs, agent-based models, or multi-agent simulation, PDs, partial differential equations, cellular automata models, system dynamics models, process-based models, which were popular last time as well, generalized linear models, machine learning, decision theory, optimal control theory, network theory, game theory, and other. And it's nice to see we have a broad spread again, with lots of process-based models, generalized linear models. We worked about 32, 33 again. Okay, great. So, if you want to see briefly how that compares to last time, we're doing all right for time quickly. Okay, so this was our disciplinary background at the opening workshop. So here, again, quite a strong mathematical number of people, and actually quite a strong interdisciplinary group.
Was biodiversity not there in that one? It was all that's just environment.
That's the next question. The next question is the biodiversity one. So this is disciplinary background, which is equivalent to this one. So we can see actually the spread, even though the numbers are different, the spread is fairly similar. Although we had more social scientists at the opening workshop, although they were still very much in a minority. Then if we look at, very quickly, the landscape system, so this is the one that has biodiversity in it, it's very much in the lead at 21, but also quite a few on agriculture and the landscape system as a whole. And we compare that with last time. Again, a similar pattern, but probably much more in purple and grey is in the climate, and I even read that from here. Climate and water. So we probably had more water and climate people last time. And then finally, we look at modelling types, many process-based models, generalised linear models, and machine learning, and again a very, very similar pattern, but with greater numbers and a much greater emphasis on process-based models at the opening workshop. So we will record that information, so we kind of know who's in the room at the opening workshop and the closing workshop, and then how that sort of leads into some of the discussions that go forwards. Okay, so but at this point in time, we're going to go into our first session, which is decision making under uncertainty. I'm going to hand over to Peter, who will chair the 2 talks. And after the 2 talks, I think it's coffee break, is that right? And then we come back for the half-hour panel discussion afterwards.